So in this video I'd like to examine the camera manager, the scene manager, and then the scene object. And then if we have time, the time manager as well. Um, or I might swap out the scene object for the time manager because the scene object is pretty large. So here we see the camera manager. We see the .h and the .cpp. Um, this was a singleton at first, and then it got brought down to just a scene level thing. There's only one per scene though. Um, yeah. So here we have some methods to create a new camera, um, get the camera from a list. This returns the current camera, the current 3D camera. This returns the current 2D camera. This returns, or this sets what current camera you want for the camera, and it takes in the name of the camera, which can then be put in uh, and found, and the camera can be found in the list. We'll look at that method in a second. You can destroy the current camera and destroy the camera manager. So now in the .cpp, we see the constructor for the camera manager. Here we see it constructs an unordered map of the cameras. Once again, I didn't feel like the cameras really needed to be ordered. And so we can access the cameras, and they also give you a nice way of giving the user an access point to the camera based off of what they put in. So I use strings and camera pointers to store the cameras. Now we see the setup for the sprite cam. I'm sorry for my coughing, by the way, and if it's loud, I've been sick for the past week. We see the setup for the 2D camera is automatic and set up in every scene, which allows for a HUD to be set up very easily without much user overhead. We orientate the 2D camera, and that's pretty much most of the default constructor for the camera class is setting up that 2D camera. Now, creating a new camera, it takes in the perspective and what we'd like the camera to be called. Make sure there's not a camera with that same name in there, and then it creates the current camera, or it creates the new camera, and I assume because they just created the camera, they want to set it as current, so I set it as current. And I return current, which is the camera that they just created. Get camera, finds it in the list, and then returns it, and makes sure that it can be found. Set current camera, sets the camera to the camera name, asserts that it is current, or that it is there. This destroys the current camera, and camera manager destroys the cameras. Okay, so now let's look at the scene manager. Here we go. Obviously, we got the .h over here. We create the scene, set next scene, in the scene, go to next scene, update the scene, draw the scene, initialize, set start scene, get current scene, default constructor. It doesn't need anything. It's a singleton, obviously, and has a couple of references to scenes, the next scene and the current scene. So here we see the .cpp, and create scene is just calls the initialize on it. End scene calls the scene end on the current scene, deletes the current scene. Go to next scene, obviously gets the next scene, sets it to the current scene, creates the scene. Set start scene, obviously sets the beginning scene. Set next scene, sets the next scene. Get current scene, returns current scene. Update scene, get instance of the current scene. then call update. Once again, current scene, call draw. Yeah. So I'm going to show the documentation for these two things very quickly before we get too far ahead of ourselves. Here's the camera manager. As we can see with the other manager, it's very simple. Gets a camera, gets the current 2D camera, gets the current camera, creates a new camera, sets current camera, and then obviously very basic things for that. Now if we go back up and go to class index and go to scene manager, once again very basic. Constructor creates the scene, draws the scene, ends the scene, gets current scene. Yeah. Now that we've gotten those out of the way, let's go ahead and look at the time manager, just so that we can get all these managers out of the way before we get into the scene level stuff, because that's going to be the bulk of what we need to look at. As we can see, time manager is the manager for game times. It's the only way to get game times from the objects, or for the objects. Get time in seconds, gets the game time in seconds, gets the frame time, get FPS, so frames per second. I kind of like that as a gamer. As we can see, it's a singleton. Yeah. And then we got a couple friend classes here to access those private methods. DG Engine is able to access the private message of ticking the frame times. Yeah. So now let's look at the .cpp. As we can see, just returns current time, current frame 1.0 divided by frame time, it's the FPS, frame time, and then the tick is where actually things happen. We get current time here, and then we and set that to the previous time. We get we set the current time based on the time freezer, time in seconds, because the time might be frozen, so we don't want to keep increasing the time for the game objects, so they'll stay still. As I said, previous is used to calculate the frame time, and then we debug out the current time and frame time. Now, let's look at the freeze time real quick. This wasn't, obviously I didn't create this. I think you did, Andre. Anyway, but it's in, it works. We can showcase it if we want by building. Go here. I'm sorry about the notifications from Facebook. Then we hit the freeze button. We can increment by 1 frame and unfreeze time. Yeah. Cool. So I think I'm going to end that video here so that I can get a large video to capture the scene object and then head into the game object systems. Thanks.